But we know that all this rambling just describes what our pocket, our profile, is. So we go to the beginning and we insert an origin shift G52. C hashtag 104 EOB. Insert. How much is this origin shift? 104 was equal to 0. So, at this moment, the origin shifts by 0. C corresponds to degrees. After thoroughly analyzing and comprehending this origin shift, I am now ready to prepare and present the subsequent origin shift, ensuring that hashtag 104 is accurately calculated as hashtag 104 plus hashtag 105. Here comes the next origin shift. When I reach the end of the program, I go back to the main program and call the subprogram for the second time. It will be 60. The next block, 104, becomes 60 plus 60, 120. I execute and shift the origin to 120. At this point, 104 becomes 120 plus 60 on 80, and I will do this 6 times. At the origin of 120, at this point, 104 becomes 120 plus 60, 180, and I will do this 6 times. Let's take a look at the speed of what I just told you. So we call the main program again, and we go. To execute the simulation, restart, start. And here we have the first shift of 60 degrees to 120. Until the last one. Done 6 times. The machine is finished. On the Fanuc, on most of the Fanucs that I find in the shop, the U corresponds to the incremental of the X, the V corresponds to the incremental of the Z, the H corresponds to the incremental of the C. I could skip the parameters and write G52H60 in my subprogram. It moves the origin with the C axis by 60 degree. The result matters. Not resetting the origin after machining is dangerous. M30 cancels shifts, but issues may arise. Continuing without resetting the axis can cause issues, especially for restarts. Always reset the tool. This simulator doesn't allow me to do this, but what matters is not the method, but the result. The result could be quite dangerous if, after finishing my machining, I don't reset the origin to 0. This could create problems. Or not, since M30 cancels the origin shifts at the end of the block. However, if you keep working on this program without resetting the axis every time you've used it and need to continue using the machine, it could create issues, especially for restarts from an intermediate block. So every time the tool gets reset. Now it's time to go finish our pocket. I've already set up tool 27 as a 6 mm diameter candle cutter to perform the finishing. Now it's time to go and finish our pocket. I've already set up tool 27 as a 6 mm diameter candle cutter to perform the finishing. So let's enter our data. Tool 27, pocket, finishing, cutter diameter, 6 cutting parameters, M13, S1004, G97. Don't think that these parameters are just fine as they are. I enter them for simulations, but then you need to check them in the catalog. As we said, we need to perform a finishing operation. So let's set up the pocket machining cycle for side finishing. Here we go. We don't want any excess material on the finished side. We'll leave just a little bit on the bottom. F is the feed rate, just like before, on one side or the complete part. So, with a safe distance for the corners, the entry looks good. So, for the alternative, we have an arc distance of 5 mm, which is fine, and an entry angle of 45, which is also good. Now let's set the exit angle properly. Now it asks me, what pocket do you want to contour? I tell it none, because I've made my nice little program, and my nice little program works well. But in this case, we have 6 pockets. So we need to modify the subprogram. We'll make it start from 6. Since we're not lazy, we'll write all 3 zeros. We also need to insert the same parameters here. The subprogram is already filled out with the origin movements, so we'll just copy it and paste it before the program call. Then we'll do a copy and insert it here. We're just going to work along the same lines as we did before. So let's simulate, restart, and start. As it changes color, you can see that it's being passed over by the smaller milling cutter. Perfect. Of course, we can't provide a product that cuts hands, so we're also going to create a bevel to smooth it out. We're going to call the T38, which is a tool I've already set up, and it's a chamfering tool. Here too, we need to set the cutting parameters in our cycle. Look at the contouring. There's internal wall, contouring, and chamfering. I recommend using this because the pocket machining with the chamfer can be a bit annoying at times. You can try it, or you can use this chamfer. For the first instruction course, there's how far your tool will extend from the wall, radial and axial feed. So the contouring feed and the approach feed. Specifically, we work with a rope. We enter vertically. Perfect. We insert the subprogram. It's the same discussion we had before. Here too, we need to tell it 60002 alter, meaning to repeat it 6 times. We also need to copy our parameters and insert them before calling the subprogram. Once finished, G52C0, and it might not even be necessary, but I always recommend 1 extra block rather than 1 less. We reset our origin, and we're good to go. Let's simulate the work done. We basically repeated the same operation 3 times. We did it once in roughing, once in finishing, and once in chamfering. If, for example, instead of having to divide it into equal and uniform parts, we wanted to divide it at 30 degrees, then at 80, then at 90, all we had to do was simply call the subprogram 3 times with the origin offsets indicated in our drawing. And you can see that now, in this case, we have the job done. What did I mean when I said, if you want to use different movements? Well, I meant this. So let's delete everything. So let's go here. Here it is. Let's delete what we no longer need. Delete it. Let's go up with the arrows, select we're going to eliminate these here. We call it back just once. Let's go into the subprogram for a moment to ensure everything is in order. We'll remove the origin movements and verify all steps are correctly followed. Then we return to the main program, and what do we do before proceeding further? We want to repeat the program twice, once at 80 deg and once at 180 deg. What do we do? G52C80 G52. C170 because the drawing asks us to make the shape at these angles, and then I copy this line and insert it after this one and after this one. Let's see what happens. You'll see that the 3 shapes are shifted by the degrees required by the drawing, so they are no longer equidistant. There's no longer a calculation done on our variables, but simply an angular repetition based on our needs. You understand that if you're struggling to deal with the variables, all you need to do is copy and paste equidistantly C60, C120, C180, and so on. 70, 120, C180, and so on, you know. You realize that if you have trouble messing around with the variables, all you need to do is copy and paste equidistant C60, C120, C180, and so on. 70, 120, C180, and so on. I mean, the program is just a little longer. Well, I hope I've explained everything about the frontal repetition of pockets, but you can do it the same way with concave or convex shapes. The concept is the same. If you like this tutorial, as always, give it a like and subscribe to the channel if you haven't done so yet. If you didn't like it, just ignore it. I thank you for your attention, and I look forward to seeing you in the next episode. Thanks. Bye-bye.